Okay, we continue with the last part for chapter 8, synchronous counter analysis. So analysis is the process of determining the output response of a given circuit to a given input sequence. So a synchronous counter can be analyzed to determine the counting sequence. Okay, so previously, uh, you are given the counting sequence and you are asked to design the uh, circuit. But now the circuit will be given to you and you are asked to determine the counting sequence. Okay, the reverse process. So given a synchronous counter circuit, we need to determine the state diagram that defines its counting. So there are 3 steps in analyzing synchronous counter. First, write the JK expressions. Second, derive the excitation table. And third, from the excitation table, draw the state diagram. Okay, let's try with one example. Okay, analyze the synchronous counter circuit shown below. Okay, so you are given the circuit. Okay, from the given circuit, okay, remember the first step is you have to write the JK expressions. Okay, so we have 2 flip-flops here, flip-flop A and flip-flop B. So we have JA, KA, JB, KB. Okay, for JA equal to 1, JB also equal to 1. Okay, KA, try to trace the wire. Okay, then the wire comes from B. Okay, comes from B, goes into KA. So KA equal to B. Next, KB. So KB, okay, you have to trace the wire. So the wire comes from Q bar in flip-flop A. So Q get so a wire from A goes into Q. So Q bar means A bar. Okay. If Q equal to A, then Q bar equal to A bar. So the wire from Q bar goes into KB. That's why KB equal to A bar. Okay. Next, once you have all the expressions for JA and JA, KA, JB, KB, okay, depends on how many flip-flops you have. Okay, so in this circuit, we have only 2 flip-flops A and B, so that's why we have JA, KA, JB, KB. Okay, remember second step, derive the excitation table. Okay, the same excitation table. Okay. Okay, so you have to fill in the excitation table based on the JK expressions obtained from the circuit. Okay, let's do it together. Okay. Okay, let's draw the excitation table together. Okay, excitation table. So since we have 2 flip-flops, so we are going to have 2 variables. Okay, 2 variables only. Okay. Present state. Okay, as usual, A, B. So once you have once you have 2 variables, you are going to have 4 possible combinations. Okay. So next state. State A prime, B prime. Okay, next. JA, KA, JB, and KB. Okay. So since we have 4 possible combination, we are going to have 0, 0, 0, 1, 1, 0, 1, 1. Okay, so convert to decimal, 0, 1, 2, 3. Okay, next. Okay, so next state, after this, okay, we have to fill in JA, KA, JB, KB. Okay, from the circuit. From the circuit, just now we have JA, JB both 1. Okay, so JA, JB 1. So put 1 here. 1, 1, 1, 1. Then for KA, KA equal to B. So B means B equal to 1. Okay. So the expression just now, we have KA equal to B. Okay, KA equal to B means you have to find the row with B equal to 1. Okay, so let's see this one. B equal to 0. Okay, KA 0. B equal to 1. So yes, 1. This one 0. This one 1. Okay, then for KB, KB equal to A bar. Okay, so we are going to find the row with value of A equal to 0. Okay, because A bar means A0. So the first row A0. Second one also A0. Okay, then this one A1. Also this one A1. So 0, 0. Okay, once you have this, okay, that oops, okay, A, K, A. Okay, so we have to determine, next step is we have to determine A prime and B prime. Okay, this one, to determine, okay, let's determine for the column A prime first. To determine A prime, okay, we consider JA, KA. Now JA, KA, JA1, KA0. So the condition, if J1, K0, this is the set mode. Okay, so the set mode, okay, if the value of A previously is 0, okay, then A prime, if it is set mode, it will become 1. Okay, next row here, JA1, KA1. Okay, JA1, KA1. Okay, this is the toggle mode. Toggle mode. So if the previous value of A is 0, A prime will be toggle 1. Okay, next 1, 0 also. 1, 0 set mode. So if the previous value is 1, so it will maintain as 1. Remain as 1. Okay, then 1, 1 also toggle. If the previous value is 1, next value of A prime will be 0. Okay, next we will determine for B, the column of B prime. Okay, B prime 1, 1. Okay, to determine B prime column, we have to consider JB and KB. If JB1, KB1, so 1, 1, it is toggle mode. So toggle mode, if the previous value of B is 0, B prime will be 1. Okay, this one also, second row, toggle mode. Previous value of B is 1, B prime will be 0. This one, JB1, KB0. Okay, if the mode is set mode, so if the previous value is 0, will become 1. The B prime will be 1. Also this one 1 0 set mode, previous value is 1, then B prime will be remain as 1. Okay, set mode. Okay, once you have A prime and B prime, okay, you can determine the next state. Okay, A prime 1, B prime 1, the value is, when you combine, the value is 3. So you write 3. Next row, A prime is 1, B prime is 0. So the value is 2. Next, this one 1 1 also 3. And then last one, A prime 0, B prime 1. So the value is 1. Okay, now you can draw the state diagram. Okay, from 0, previous state 0 goes to next state 3. Then from 3 goes to, okay, 0 goes to 3, 3 goes to 1. Okay, then 1 goes to 2. Oops. Okay, 1 goes to 2. And then the last one, okay, 2 goes to 3. Okay, so this is the state diagram that you will have. Okay, next. Okay, let's check for the answer. Okay, this is what we have done. Okay, you can go on your own. The slide, actually the slide is actually the slide is showing what I have explained just now. Okay, so you can go through on your own. The same thing actually. So the answer is, yeah, 0 to 3. Okay, 0 to 3, 3 to 1, 1 to 2, and then 2 to 3. Okay, 1 to 2. Okay, doesn't matter how you draw it, as long as you have the correct arrow to the correct numbers. Okay, so the counting sequence 1 2 3. Okay, 1 2 3. Okay, so by that we finish chapter 8.